Hello, I'm Tom Namola. I'm a product development and applications engineer for Abrasive Technology. Today we're going to talk about coolant application techniques when using single-layer super abrasive wheels. Okay, well let's get into talking about coolant application techniques. Usually the first question that will come up is, what type of volume and pressure do I need to properly apply my coolant? Well, there are really two drivers of the pressure and volume gain. One is the size of the wheel in the grind zone, because of course you need enough volume to cover the width of the grind zone. The other relating to pressure and volume is you also need a minimum velocity of the coolant for it to be effectively carried with the wheel through the grind zone. As you probably know, most of these types of wheels are running between 6,000 and 9,000 surface feet per minute. This velocity creates an air barrier around the wheel. You must be able to overcome that air barrier with the coolant for it to effectively do what it needs to do in the grind zone, as we discussed in the previous segment. So, we've also touched a little bit on different types of coolant. This relative velocity to the wheel is kind of dependent on your coolant type. With a straight oil coolant, you can usually get away with a coolant velocity in the range of 60 to 70% at minimum of your wheel velocity. When you're using the synthetics and the soluble oils, this velocity requirement now goes up to about 90% to have the coolant effectively do what it needs to do. Again, due to the lubricity and the way the different materials are able to penetrate the air barrier and cling to the wheel to be carried through the grind zone. Now, this velocity requirement also leads into the next thing that we want to talk about, and that's nozzle design. A good nozzle will have a lamellar flow of liquid through the nozzle. What this means is the stream diameter does not increase significantly from the point that it leaves the nozzle to the point that it actually comes in contact with the wheel. Any expansion that the stream does go through reduces the velocity. So now what this means is if you're not using a very good nozzle, you're going to have more pressure and more flow to hit the velocity target that you want. And this flows right into the next point, which is the aim of the nozzle. If your stream is not coherent, it makes it very much harder to aim. An aim point is again another factor that we need to consider. The aim point of the coolant really needs to be hitting on the wheel just above where the wheel goes into the grind zone. This makes sure that the velocity and direction of the coolant are able to be carried through the grind zone. So in summary, having a solid aim point and a good nozzle design, along with the width of the grind zone, will help you determine the volumes and pressures that you need to deliver your coolant to effectively grind your material. Thanks for watching, and please feel free to reach out to us if you have any questions concerning your specific application.